Well, welcome back to our class on systems design, where we're looking at system analysis and design from Dennis, Wixom, and Ross' point of view. And we're now getting into the second major phase. In the beginning, we kind of looked at the whole system development life cycle for these four different phases, but now we're going to drill down deeper. And so for this first one, we're going to be talking about requirements determination. And so this is going to be thinking more in depth in terms of the analysis. And so we'll have 4 lectures, 3 chapters, and then an appendix that are related to the analysis phase that we'll be going over. So this is the planning phase. And so what we're looking at for this particular chapter is requirements determination. And let's go ahead and get started here. So during the analysis phase, the analyst determines the functional requirements for the new system. Now, in this chapter, we begin by describing the analysis phase and its primary deliverables, the system proposal. The concept of a requirement is explained, and several categories of requirements are defined. The purpose and structure of the requirement definition statement is outlined. Techniques to elicit requirements are discussed, including interviews, joint application developments, JAD, sessions, questionnaires, document analysis, and observation. Finally, several requirements analysis strategies are described to help the analyst discover the requirements. And so here are the objectives. So we want to explain the analysis phase of the system development lifecycle. We want to describe the content and purpose of the requirement definition statement. We want to classify the requirements correctly as business, user, functional, or non-functional requirements. We want to apply the requirement elicitation techniques, as I mentioned, but here we see them: interviews, joint application development, JAD sessions, questionnaires, document analysis, and observations. We want to define the role that each requirement elicitation technique plays in determining the requirements. Which one should we use? And so we'll be thinking about that, and we'll describe several analysis strategies that the analyst can determine for uncovering what the requirement should be. So the analysis phase, so the goal is to develop a clear understanding of the new system's requirements. So we have the as is and to be concept that we'll be dealing with. So first of all, we need to understand as is how the system is operating today. We want to be identifying what are the desired improvements and then develop the baseline for what the to be system concept will be. We want to be using critical thinking skills to determine the true causes of problems. Thus, system engineering can be very much of a help there. Apply the knowledge of information systems and businesses to outline ways to solve the problems in the new system. So once again, with this textbook, we're focusing on information systems, but we can also broaden that to other types of complex systems. To move the users from here to there, an analyst needs strong critical thinking skills. So it's unrealistic to expect the true requirements to be delivered during a few conversations with the business users. And so we're thinking of a type of capability that it's very much conversant. You're getting the requirements from users, from the stakeholders. And so thus this moves us in a certain direction of how we're going to do the requirements development part. So a number of techniques and tools can be used by the analyst to facilitate this process of discovering requirements. The final deliverable of the analysis phase is the system proposal. So this is a document compiling the detailed requirements, definition statement, use cases, process models, and data model together with a revised feasibility analysis and work plan. So what we have at the conclusion of the analysis phase, we have the system proposal, and we're able to present that to the approval committee, usually in the form of a system walkthrough. So you get a kind of a little bit of a day in the life of experience of what this to-be system that you're trying to propose. Before moving into the design phase, the project business value should be reviewed to ensure that it remains positive. We talked about that already, thinking about return on investment and other characteristics. The line between the analysis and the design phase is very blurry, at least for information systems. In many ways, determining requirements is the single most critical aspect of the entire system development lifecycle. So keep that in mind. Something that's really important. You have to figure out exactly what you're going to do and be under contract for building that. And this is what we're trying to get our arms around. During requirements determination, the to-be system concept is easy to change because little work has been done yet. As the system moves through the subsequent system development lifecycle phases, it becomes harder and harder to return the requirements determination and make major changes because of all the rework that is involved. And so that system engineering really pays the early on phases to find these things and get a solidified baseline early. So in requirements determination, it is performed to transform the system requests high-level statement of business requirements into a more detailed, precise list of what the new system must do precisely. The system list of requirements is supported, confirmed, and clarified by the other activities of the analysis phase. So what is a requirement? A requirement is a statement of what the system must do or what characteristics it needs to have. And so what are the things? There's the various types of requirements, what the business needs, and so these are business requirements. What the users need to do, those are user requirements. What the software should do, functional requirements. What are the characteristics of the system should have, and those are non-functional requirements. And finally, how the system should be built, and these are system requirements. And so this is from a perspective, thinking it from an information system type of development. Maybe there would be some other nuances in terms of the categories of requirements. And if you see details in my system engineering course, you'll get a chance to see that flavor as well. Okay, for the business requirements, in the system's request, there are statements that describe the reasons for proposing the system development project. These statements reflect the business requirements that the system will fulfill. When the system development project is complete, success will be measured by evaluating whether the stated business requirements have been achieved. Therefore, they provide the overall direction for the project. Now, let's consider user requirements. So what the user needs to do to complete a needed job or task. And so you're codifying those details. You focus on the user tasks that are integral to business operations. And it's trying to capture an understanding of the user tasks, then that helps to reveal the ways that the new system can support those tasks. Maybe there's going to be a slightly different way that it's done with the to-be system versus the as-is. Functional requirements, so a process the system should perform as a part of supporting a user task or information the system should provide as a user performs a task. And it specifies the support the system will provide to the users in fulfilling their work tasks. So here's just a little bit more on functional requirements. And so you can be thinking of process-oriented and information-oriented categories here, subcategories. And so for process-oriented, it's a process that the system must perform, a process that the system must do, versus the information-oriented, it's the information the system must contain. And you can read the rest of the things here on this chart. I refer you to the textbook or just pause the video when you can take that in. Next, let's think about the non-functional requirements, according to the authors when we're dealing with this type of a system, and they are the quality attributes, the design and implementation constraints and external interfaces which a product must have. This requirement category includes important behavioral properties that the system must behave. The behavioral properties a system must have, we have operational, performance, security, and culture and political. So for operational, we're dealing with the physical and technical operating environment. For performance, we're considering speed, capacity and reliability needs. Security, we're having access restriction and needed safeguards, cybersecurity, and all that. And then for culture and political, we're dealing with issues that will affect the final system. And we'll come back to non-functional requirements in chapter 7, so you can keep that in mind. So we have a couple of charts here that gives us a little bit more perspective on non-functional requirements. And so we have operational, performance, security, and cultural and political. And so for operational, they're the physical and technical environment in which the system will operate. And we have some examples over here: the performance, the speed, capacity, and reliability of the system, the security, who has the authorized access to the system under what circumstances. And then for the cultural and political, we want to consider cultural and political factors and legal requirements that affect the system. Okay, what about the process of determining the requirements? Both business and IT perspectives are needed to determine requirements during the analysis phase. System analysts may not understand the true business needs of the users, and the business users may not be aware of promising new technologies. So that's why getting both of these perspectives are helpful. The analyst must also consider how best to elicit the requirements from the stakeholders. There are a variety of elicitation techniques that can be used to acquire information. The evolution of the requirements definition must be carefully managed, and keeping the requirements list tight and focused is key to a project's success. So first, we want to think about the requirements definition statement. The requirement definition statement is a straightforward text report that simply lists the functional and non-functional requirements in an outlined form. Usually this is called the requirements definition. Requirements are typically identified by numbering. Sometimes requirements are prioritized in the requirements definition statement. The most obvious purpose of the requirement definition is to provide a clear statement of what the new system should do. A critically important purpose of the requirements definition is to define the scope of the system. So here's some sample functional requirements. And so we're coming now specifically for drone tech. And so this is the notional company and capability that we will be using as we progress through the textbook. And so we have the drone sales management. The system will enable drone sales order creation. I'm not going to go through all of these, but you can see that. And then for drone customization shop management, just one example, the system will send a parts request to needed drone components on an order to drone inventory department. And then for non-functional requirements for this type of information system, we have operational performance, security, and cultural and political. Operation, the system should run on a tablet device to be used by a salesperson. And so what kind of operating system, all kinds of things that you need to think about the performance. The system shall provide response times of 3 seconds or less. Security, the customer account should be maintained securely. And cultural and political, the company policy says that all computer equipment is purchased from Dell. That would be sort of an example of a stipulation there. So there's more examples. I'm just giving a few that you can see and think about. Well, next, let's talk about the requirements elicitation techniques. And so talking to stakeholders, users, how are you going to start to glean that information and then get it into the form that you can have it in a requirement that you can build to? An analyst knows that there is a problem to be solved and therefore must look for clues that uncover the solution. Unfortunately, the clues are not always obvious, so the analyst needs to notice details, talk with witnesses, and follow leads. You can see use the word analyst a lot, and so from my system engineering course, I would substitute system engineer, but I'll let you use whatever term you'd like. The best analysts will thoroughly secure Thoroughly search for requirements using a variety of techniques and make sure that the current business process and needs for the new system are well understood before moving into design. You want to use every interaction with managers and users to garner interest, support, and enthusiasm for the project. That's all good things to do. You want to choose participants carefully. Stakeholders are the people who can affect the system or who will be affected by the system. And you want to make respectful use of people's time. So here are 5 different elicitation techniques, and we'll go through each one of these one at a time. First, interviews. Second is joint application JAD sessions. Third, we will be using questionnaires. 4, we'll use document analysis. And finally, observation. So first, for interviews, most important and most used fact-finding technique is what we have with this option. The systems analyst collects information from individuals face-to-face. So who should we interview? Managers in early project stages to get broad understanding. We also want to consider staff that can provide details and specifics later. And then for political issues, they are important. So it may be necessary to interview influential people, even if they are not too knowledgeable. And there's 2 approaches, either a top-down or bottoms-up. So top-down, you go from broad to specific, and this is most common. And the other option is a bottom-up, where you go specific to broad. It's useful for collecting details. So you can be thinking about which one that you might want to be using for what type of individuals. What would we do in terms of the questions? You can have closed-ended questions. You're asking for a specific answer, open-ended questions, or probing questions. And so closed, you're looking for, X or Y, kind of something like that. Open-ended questions, you want to be seeking more wide-ranging response from the individuals. And so you can be seeing some examples over here. And probing, follow on to what just has been discussed so that the interview can learn more. And so you get some information, but you need more. You want to make sure that you fully capture everything that is being sought for, and so you can get probing questions to help out. A little bit more on interviewing. You should not ask questions about information that is readily available from other sources. Your interview question should anticipate the type of information the interviewee is likely to know. No type of question is better than another, and usually a combination of questions is used during an interview. So here's just a pyramid look at the top down and bottoms up. We've already talked about that. So high level on the top, medium level here, and then low level. And so either we go top down, you go or the bottom up. So top down, you go to the top of the pyramid, you get wider. Bottoms up, you start with wide and you get narrower. So what are the strengths and weaknesses of interviewing? So first, for strengths, the interviewee can respond freely and openly to questions. The interviewee can be asked for more feedback, and questions can be adapted or reworked for each individual. And finally, interviewees' nonverbal communication can be observed. And you want to have some way to be able to respond and include that in the what you're trying to capture from that interview. Weaknesses, it's very time consuming and therefore costly when you're dealing with this type of fact-finding approach. Success is highly dependent on the systems analyst's human relations skills. And so not everybody would be a good interviewer, and it may be impractical due to the locations of interviewees. That would also be a huge cost. If it's face-to-face, you're going to have to get your interviewers to where the folks that you want to interview are located. In terms of preparing for the interview, you should have an interview plan that lists the topics and issues that you will ask in the appropriate order. You want to confirm the areas in which the interviewee has knowledge so you do not ask questions they cannot answer. Structured interviews with closed-ended questions take more time to prepare than unstructured interviews. when you schedule the interview, inform the interviewee of the reason for the interview and the areas that you will be discussing. So thus they can be prepared. When you conduct the interview, the first goal is to build rapport with the interviewee. You want to set them at ease. You want to have good communication. It is critical to carefully record all the information that the interviewee provides. So you want to be sure to take lots of notes. If you do not understand, be sure to ask, not be afraid to ask, quote, dumb questions. You want to be separating fact from opinion, as the interview draws to a close. Give the interviewee time to ask questions or provide information that they think is important. And then briefly explain what will happen next. And then in the post-interview, the follow-up after the interview is over, the analyst or system engineer needs to prepare an interview report. The interview report describes the information from the interview. It contains interview notes. Often the interview report is sent to the interviewee with a request to read it and inform the analyst of clarifications or updates. Next, we have the joint application JAD development. This is an information gathering technique that allows a project team, users, and management to work together to identify requirements for the system. Its goal is to produce complete requirements definition document. It directly involves the project sponsor, key managers, and key users with system analysts. This is something that will require a trained facilitator and requires a comfortable facility for long-term intense group work, preferably an offsite, and it can be expensive but valuable. You can have JAD or electronic JADs, and so any group activity may experience problems with group dynamics. EJAD helps group overcome group dynamic issues, dominance, status, differences, fear of reprisal. So EJAD provides ways for members to contribute, comment on, and rate ideas anonymously, and it requires a trained EJAD facilitator and groupware software. So a little bit more on JAD. Participants are selected on the basis of information that they can contribute to provide a broad mix of organizational levels and to build political support for the new system. Should be released from regular duties to attend when you're going through these sessions. JAD sessions can run from as little as half a day to several weeks. JAD sessions usually are designed and structured along the same principles as interviews. Closed-ended questions are seldom used, and it's important to prepare the analyst and participants for the JAD session. So how do you conduct one of these JAD sessions? Most JAD sessions will try to follow a formal agenda, and publishing that in advance is a good option. Most also have formal group rules that define appropriate behavior. The JAD facilitator performs 3 key functions. They ensure the group sticks to the agenda. They help the group understand the technical terms and jargon that surround the system development process, and they record the group's input on a public display area. The facilitator should try to help the group resolve issues, and it is common for the JAD participants to make use of several tools during the JAD session to fully define the new system. There's also follow-up for a JAD session. So there's a report that is prepared and circulated among the session attendees. The post-session report is essentially the same as the interview report and usually takes a week or 2 to prepare. We also have questionnaires, and so it's a set of written questions for obtaining information from individuals. It's mass-produced and distributed. The respondents complete the questionnaire on their own time. Facts are collected from a large number of people while maintaining uniform responses. When dealing with a large audience, no other fact-finding technique can tabulate the same facts as efficiently. So this can be an efficient way of getting some information for requirements development. So the first step is to select the individuals to whom the questionnaire will be sent. Users, for example. Developing good questions is critical for questionnaires because the information on a questionnaire can't not be clarified. You must have a clear understanding of how the information collected from the questionnaire will be analyzed and used. Questions should be relatively consistent in style so that the respondent does not have to read instructions for each question. The key issue in administering the questionnaire is getting participants to complete the questionnaire and send it back. And so giving a deadline, specifying the importance, all of that. So, well, with this one, we have to be making sure we have good questionnaire design. So we want to begin with non-threatening and interesting questions, group items into logically coherent sections, do not put important items at the end of the questionnaire, do not crowd a page with too many items. You want to avoid abbreviations that they may not be familiar with, avoid biased or suggestive items or terms, the number of questions to avoid confusion, and you want to pre-test the questionnaires to identify confusing questions. Finally, provide anonymity to respondents. So what are the strengths and weaknesses of this approach? First, for the strengths of questionnaires, most can be answered quickly. It's relatively inexpensive, allows individuals to maintain anonymity, and it can be tabulated and analyzed quickly. The weaknesses, the response is often low. And so the big question is, how do you motivate individuals to participate? What about incomplete questionnaires? So if they're incomplete, does that make them worthless? That may be. It tends to be inflexible. The body language cannot be observed, so you're not really positive when you get response how they mean them. You cannot clarify a vague or incomplete answer to a question if it's anonymous, and it's difficult to prepare a successful questionnaire. In terms of some practical tips, you want to determine what facts and opinions must be collected and from whom you should get them. You want to write the questions. You want to use pre-test the questions on a small sample of, quote, typical respondents, not just other system analysts. And it's helpful to use random sampling if necessary. Another thing we can do is document analysis. You can collect facts from existing documentation, org charts, history that led to the project, documentation from previous system studies and designs performed. You want to analyze facts to determine currency. Even outdated documents may be useful, and you must recognize what is current and what is outdated. Then you want to analyze to understand the documentation, take notes, draw pictures, and use system analysis and design tools to model what you are learning or proposing for the system. Finally, you want to use appropriate sampling techniques. So for some practical tips, good place to start is to be looking at history, vocabulary, to engage with key personnel. You want to learn as much as you can from existing documentation. People get annoyed being asked about things you could have learned from existing documentation. So make sure that you cherish people's time and use it accordingly. So here's an example of a sample document analysis. And so this is for a veterinary clinic. And so what name? Do you mean the name of the pet or the name of the owner? That would be something that's not necessarily clarified. There may be some other, if it turns out that there's additional information that has to be added on the form, there's probably some things that are missing. What happens when things are not included, like the area code? And so this can be ambiguous as a result if they're trying to have contact information. And the form does not allow for extensions. And so if they have a work number and they have an extension, this would be an issue. So this is the kind of thing that you could be thinking about for document analysis and how this could be impacting what you're trying to do with an information system, since that's the focus of what we're trying to cover in this class. Observation, the act of watching processes being formed is a powerful tool to gain insights into the as-is system. It's you can use it when the validity of the data collected using other methods is in question. It can be useful when the complexity of certain aspects of the system prevents end users from providing a clear explanation. So you may see that they use certain processes, but there's other things that they augment it that maybe has turned out on the job training that you may not have picked up without getting this extra perspective. So what are the strengths and weaknesses of observation? For strengths, data gathering may be highly reliable. You can see exactly what is done, and that is really good. It's relatively inexpensive, and um, you can do work measurements to get some quantifiable statistics and various other things. Weaknesses, people may perform differently when being observed. So maybe you're not getting a true representation. The work may vary in difficulty and volume. Some activities may take place at odd times, and the tasks being observed are subject to various types of interruptions. And so those are things you have to think about. In terms of practical tips for observation, you need to properly plan for observation, obtain approval, and inform people of your purpose. You want to conduct observations first when the workload is normal, followed by observation during peak periods. Obtain samples of documents or forms that are being used by those being observed. Apply the sampling techniques discussed earlier for observations and review observation notes with appropriate individuals. So here are just examples of these different types of requirement elicitation approaches: interviews, JAD, questionnaires, document analysis, and observation. And what are the things that you're hoping to get? What type of information? What depth do you need? What breadth do you need? What about the integration of information? How much user involvement was used for this requirement approach, elicitation approach? And finally, how much does it cost to perform this? So you can see this is a fairly useful table to give you a perspective on maybe you're going to do one, maybe you're going to do several to give you a rigorous way of making sure you capture the requirements. So what are the various types of requirement analysis strategies? Problem analysis, root cause analysis, duration analysis, activity-based costing, informal benchmarking, outcome analysis, technology analysis, and activity elimination. And so all of these are things that you want to be thinking about as a system engineer or as an analyst, however you want to think about it. All of these things need to be part of the process. So to identify small improvements, we can be considering problem analysis and root cause analysis. And so that would be these first two. You want to ask users to identify problems and solutions. Improvements tend to be small and incremental, and it rarely finds improvements with significant business value. For root cause analysis, you want to challenge assumptions about why problems exist, and so think out of the box. You want to trace symptoms to their cause and discover the quote real problem. Those would be things you want to be thinking about. If you want to be identifying moderate improvements, the goal is to improve efficiency and effectiveness. You want to expect moderate changes to existing system. You want to expect moderate impacts and value to the organization. So what type of activities would this get into? Duration analysis, activity-based costing, informal benchmarking. So for duration, it requires a detailed explanation of the amount of time it takes to perform each process in the current as-is system. For activity-based costing, you want to examine the cost of each major process or step in the business process rather than the time taken. For benchmarking, it refers to studying how other organizations perform a business process to learn how your organization can do something better. So when we're trying to consider major improvements, the goal is radical redesign of a business process. You want to expect impact and value to the organization. The existing system is meant to be, quote, obliterated. And so activities focus on envisioning the system in a new way. So we get into outcome analysis, technology analysis, and activity elimination. What can you streamline? For outcome analysis, you want to consider the outcomes from the customer's perspective. Consider what the organization could enable the customers to do. You want to consider using brainstorming on desirable customer outcomes that enable that's enabled by information systems and new technologies. And so you integrate new information in new ways, and how is that going to be helpful to your customer? For technology analysis, the analyst or system engineer list important and interesting technologies. The manager lists important and interesting technologies. The group reviews each list and identifies how each technology might apply to and benefit the business. So system engineers or analysts, and managers, you can compare their points of view, and brainstorming with special emphasis on technology use. And so start to think of what if we add the latest and greatest type of technologies that we could leverage. In terms of activity elimination, you want to identify what would happen if each organizational activity were eliminated. You can use a quote force fit to test all possibilities. You can consider that you insist that all activities are potentially eliminated, even if it seems preposterous. So you're being rigorous in your activity elimination. And finally, the brainstorming technique that helps to overcome, but we've always done it this way, limitations on thinking. So you want to be pushing a little bit beyond that, so you can be having true possibilities for reimagining what you would be doing and how you would do it. Okay, well, let's just go through a chapter review. We have 3 charts, since there's been a variety of things that we've talked about. First, we've explained the purpose of the analysis phase. We discussed how its purpose differs from the design phase. So we do the analysis phase first. We discussed the contents and purpose of the system proposal. We explained the concept of a requirement in an information system development project. We discussed the difference between a functional requirement and a non-functional requirement, mostly focused how we would vision this for an information system. We explained how both contribute to our understanding of the new information system. We discussed how to use interviews when eliciting requirements. We discussed how to use JAD when eliciting requirements. We discussed how to use questionnaires when eliciting requirements. We discussed how to use document analysis, and finally observations for eliciting requirements. And then we had a summary table that gave you a comparison. You may end up wanting to use one or more of those approaches to get you exactly what you want. We described the problem analysis strategy and how it contributes to the analysis phase. We described the root cause analysis strategy and how it contributes to the analysis phase. We described the duration analysis strategy and how it helped with this analysis phase. And we described the activity-based cost strategy and how it contributed to the analysis phase. Plus, we have several other things that contributed towards the analysis phase: the informal benchmarking strategy, the outcome analysis strategy, the technology analysis strategy, and the activity elimination strategy. So there's a lot of things that we got a chance to get a good introduction in this chapter. And I'll refer you to the textbook to be thinking about a lot of the terms that we brought in. And so this is a listing of them, the first slide, and here is the second slide that you can, if there was a word that you weren't familiar with that I used, you can be referring to the textbook to get some more context of that. And so I welcome you to do that. All right, thank you very much.